We know there is no logarithm of 0 over the real numbers because the logarithm as x goes to 0, the logarithm goes to minus infinity, so there is no log of 0. But what about complex valued logarithm? Is there a log of 0 in the complex plane? Well, there would be a value y, a complex number y, that is the log of 0, if and only if e to the y is 0, where this is the complex valued exponential function. So the question is there a 0 in the complex valued exponential? So is there a number y, a complex number y, such that e to the y is 0? Well, if so, that complex number would have the form a plus bi, with a and b real numbers, and I can rewrite this as e to the a times e to the bi, and using Euler's formula, that's e to the a times cosine b plus I sine b. Now, this is e to a real number, which I know is never 0. That is the real valued exponential function, which never vanishes. So then, is this number that I'm going to call alpha, is that 0? If so, well, that is like some complex number alpha, cosine b plus I sine b, but that number, the absolute value of that number is the square root of the square of the coordinates, which is cosine square b plus sine square b, which by trigonometry, that is 1. So that number is actually in the unit circle, and therefore is not the 0 number. So this alpha is non-zero, which means that e to the y is never 0. And that's in fact because the exponential function, the complex valued exponential function, never vanishes. So there is no number y such that e to the y is 0, and there is no value that gives you ln of 0.